Welcome to the Monty Hall Game Show. Come on down. You get to choose one of the doors, door number one, door number two, or door number three. There is a brand new car behind one of the doors, and there are goats behind the other two. This was really a game show, and I think it may have been early 70s, possibly late 60s, and it was at a time when goats were not considered, I guess, to be very valuable. By the way, there's Monty Hall. This is a real person, a real game show. Okay, so you choose one of the doors. Let's say you choose door number three. And then Monty says something very interesting, or does something interesting. He reveals that behind door number one is a goat. And now he says to you, you can stay with door number three if you want, or you can switch to door number two. Do you want to switch? And then the crowd goes wild with everyone saying, switch, stay, and so on. And it's really interesting because you have to ask yourself, is Monty trying to swindle you? Can you use probability to your advantage? It seems like when you first started the game, you had a 1 in 3 chance of guessing right. Now it seems like you have a 50-50 chance. And the question that we're going to resolve using code is if it is in fact to your advantage to switch. And let's just say, I'm not going to go in depth with how to do this analytically. You could apply Bayes' rule. It's kind of a theorem that you can deduce from conditional probability to actually get the correct answer. But people have debated this pretty intensely over the years, even though there is a clear mathematical solution. So one way to do it is using probability theory. The other way is with code. So in this first lesson, what I want to do is I want to share some code with you that you can use to potentially turn the Monty Hall Game Show into a Python program, and then to run it, say, I don't know, thousands of times or more to figure out the correct probability. Okay, so there are a lot of different ways you could code this. So let me just give you some pointers here. First of all, I like the idea of putting the doors into a list. Okay, so there's a list of doors, and the prize is randomly behind one of the three doors. So what we want to do is randomly choose one of three doors. Now, by the way, be sure to code this with me, okay? If you haven't already, open up a new collab window. Obviously, you don't need these doors 1, 2, and 3 here. And what you can do is import the random library and then use random.choice. And this is a really nice method. What it does is it'll randomly choose one of the elements of the list. So if I run that by pressing Shift Enter, you can see the first time it gives door number one. Now, whenever I do randoms, I always run them multiple times to see if I get everything, to make sure I have the code right. So I got door number three again. This sometimes happens. Oh no, 3 threes in a row. There's 2. So it seems to be working correctly. Okay, so that's one key piece that you're going to need. Now, if you are like going to choose to use a list of doors, the next part is actually tricky. Okay, because note that, okay, so there's a door behind, in this case, this was number 2. And then the user has to choose a door 2, right? Like you could choose 2, you could choose 1, you could choose 3. But here's why it's tricky. Because let's just say that the user choice, I mean the user door here, is 1, okay? And then when Monty now reveals the goat, okay, you've already chosen 1, the prize is behind 2, so he has to show you 3, okay? But what if you pick 2? If you pick 2 now, Monty could show you 1 or 3. And it's supposed to be random again, so you would need a way to another random selection. So how can you keep track of all this using code? Well, the list of doors you can actually shift. Okay, so there's the user door, we've got the prize door, but now there's the door that he's going to eliminate, right? And again, you have 2 different scenarios. You have if user door equals the prize door, you know, for instance, you might want to call this the prize door. and that's one setup. And if they're different, it's a different setup. So let me show you what I mean here. So now if I run this, we don't know what the prize door is, which is pretty cool, right? You can pick whatever you want. So say user door 2. And now the scenario where you never switch doors is pretty simple, because you could say if prize door is equivalent to user door. I mean, this wouldn't complete the game here, but just to give you an idea, you could print you win. And again, this would be like, hey, you never switch. So are they equivalent? Well, let's find out. It's kind of nice, like it won't print it out if it's not right. So if we could do an if else, you could print you lose. Okay. So if I run that, you lose. You don't note, by the way, this is a good test too. It's always good to test your code. The prize door's already been chosen, so if you check 1, 2, and 3, eventually you should win. You lose if you pick 1, so it should be 3. Because we're not running the previous cell of code again, you win. Okay, but you want to allow for the user to switch doors. So one way, let me show you one way you can keep track of this. You can actually remove. So I think is it doors.remove. Now let's see what happens if I remove the user door. Okay, now when I run that, nothing will happen, but I can show the doors again. You see, door number 3 has been eliminated, and so you're only left with doors 1 and 2. Now this is interesting because you could also eliminate the prize door. Now in this case, they're actually the same. So I'm not explaining it well because it gets into a lot of changes that you have to carefully track. And on this video, I'm not actually showing you how to write it. I'm showing you the key things that you can use to write it. In the next video, I'll show you the way that I did it, but I really want you to try it on your own first, because that's how you're going to learn. It's very hard to get this right in the first try. So again, what we have here, let me just review. We have a list of doors, 1, 2, and 3. The prize door is a random choice of the doors. Okay, by the way, it's kind of fun. We can do it again. Okay, now there's a new prize door. And again, if for the simple case of, hey, you never switch, this will work, this chunk of code. And you could decide, oh, no, I want to change it. Last time it was 3, maybe this time it's 2. Well, you lose. Okay. By the way, you can actually do these 2 things over and over again to probably get the correct probability. But we want to do it right to account for the switch. So what you can do is you can start to change the doors that are available, right? Like right now, you know, if we remove the user door, but what if we also remove the prize door? Now in this case, they're not equal, so you'd have to account for that. And you can see that there's only one door left, which is door number 3. Now, how can you access that when you have one door left? Well, it's simple. You can, sorry, not doors 3, to get it's the first element in the list, it's the only element. And so that doors bracket 0, doors index 0, will give you the element of the list. So I believe that those are all the key pieces that you actually need to play the game. I'm just looking at some passcode to see. Yeah, I think that's basically it. But then what you actually have to do is you have to keep track of it. Okay, so part 1 of it is, can you play the game? But part 2 would be, okay, so if you're going to play the game, you know, anything can happen one time. The point is, what if you played 100 times or 1,000 times? And just to give you an indicator, let's look at combining actually these 2 into a game. And again, this is the game where somebody never switches. Okay, so what I'm going to do here is I'll just actually put it all up here maybe and copy this and show you how to turn this into a function that you can repeat. And basically what we're going to call it, let's call it play game. Maybe play Monty game. I just play Monty. Okay, so so the user door would be what you could choose, and that would allow you to have a regular choice and then to switch it. Okay, that's called a name parameter. I'll talk more about it in a moment. So there we have the doors. You could import the random in here or outside. And you got the prize door. Now the user door has already been chosen within the function, so you don't need that here. And there's one other, I'm just tabbing everything because it's a function, but there's one other thing you want to do here. If you're going to like run this a bunch of times and keep track of how many times you're actually going to win, you don't really want to do like this print out because it'll just be a bunch of prints. How about you count it as 1 if you win and 0 if you lose? Okay. So first of all, let's check this function to see if it actually does what we want it to do. Okay, so function worked, and I can just call it now because I've already have the user door chosen as 2, but you can change it. And you can see I win because I got a 1. Okay, and if I play it again, I lose. 50-50, right? Well, now that it's working properly, and just to show you by the way how to change it, like you could pick 1, 2, or 3, you know. Okay. And so now to how do you, the final question then is, but how do you keep track of it all? Right? So that's doing it each time. Well, you would want to use like a list here. Well, a list where I'm not speaking correctly. You want to use like the range. So if you want to play 100 times, you could just say for I in range 100. Okay, that's Python syntax for doing something 100 times. And what we can do is we can play Monty 100 times. Okay, but here's the thing. And you know what the heck, I'll leave in the user door thing. And you can also randomly choose your door, or you could always pick the same one. Okay, so you want to keep track of it though. So before you play it, you haven't won yet, okay? So you have 0 wins. But now what this is right here, this is a number, okay? This is the number of, like you see how it's 1 or 0? It's just a number. And so when you win, okay, what you can do is you can add to your win count. Plus equals means wins equals wins plus play Monty. So if this number is 0, you don't add any wins. But if it's 1, you will actually add wins. Okay? So that will count all your wins. And then so finally what you can do then, you can show the probability. And so the probability you could, well, first of all, what is the probability? The probability equals the wins divided by the number of times that you play. Now those are often called trials. In this case, it's 100. But I think you would also want to switch that. So you could say like trials equals 100 and then put trials in here. Okay. And so what this will do now, you divide the wins by the total number of trials, right? So in this case, it's 100. And this is going to show us how many times did we win. And you could print it out by just the number, or you could add text to it. Let's just print out the probability. So let's see if this is correct. So just to go over this code again, wins is 0. You haven't won any yet. You're going to play 100 times. You're going to loop through 100 times. No, you don't actually use the I, but that's the right syntax for it. And then we're just adding up the Monty Hall Game Show, which is a function previously defined. And we're scoring every time there's a win, right? We add to our win count. Okay? And then the probability is just the wins out of 100. So if we win like 30 times out of 100, we should get 0.3. If we win 50 times out of 100, we should get 0.5. So here I go, run the code, and I win 23% of the time. And that's by never switching. And you can tweak this, do whatever you want with it. It's fun to do it again. And getting better. Oh man, is the computer figuring it out? Is it just getting better? And the other thing you can do is, 41. You can change the number of trials, which is nice. So for instance, instead of 100, you could do 1,000. You know, will you get something more exact? Okay. You could do 10,000. 3312. And I'm going to pause it right there. And I want you to try on your own. You can reference this code to help you. But try it on your own. See if you can try to build the Monty Hall Game Show as it is. And what you have to do is you have to give the user the option to switch. Okay, and you've got to, again, account for whether the switch is going to, um, it's two things, right? If Monty has to randomly pick which door or there's only one choice left. Okay, and I can tell you too, having done this a couple times, I did it recently and definitely did not get it right the first time. I had to go back through the code and make multiple changes. So it's a little tricky, it's not like profound or anything, but because you have like branches and you got to be careful of what you're keeping track of and how. Okay, so have at it, and after you're finished, check in with me with the next video.